Okay, so in this problem, it says a new ride spins you in a vertical circle of radius 6.5 meters so that you have an angular velocity. So they're giving you the omega here. An angular velocity of 1.8 radians per second. If you weigh 950 newtons, what would be the force that the seatbelt needs to apply to keep you from flying off the ride at the highest point? At the highest point, that is where you most need a seatbelt. Because if you're going to be flying off, that's where the force is greatest. That's where, I mean, when you're down here, you don't even need a seatbelt. You're just going to be pushed further into the seat. But when you're up here, you need a seatbelt to change your direction. So if I draw my forces at the highest point, I'm going to have the weight and the normal force are both going to be directed towards the center of the circle. So the weight and the what we call the normal force, that's the force from the seatbelt. Now I don't have to make a guess as to what direction the normal force is here, because if it's a seatbelt, I know it's going to be down because it keeps me in the ride. Remember I told you that in some of these problems, you may not know, based on how fast the ride's going, whether you're still going to be on the seat of the ride, or whether the seatbelt is going to be pulling you off the ride, and you need, or whether the seatbelt's keeping you from flying off the ride. You make a guess in that example. You make a guess, and if you guess right, your answer for the normal force will be positive. If you guess wrong, then the answer will be negative. Don't change anything. Just leave your picture the way it is and leave your answer as negative. But in this one, they're literally telling me that you need a seatbelt. So I'm guessing that, I'm not even really guessing, I'm just going to assume then that means that the normal force is down because it's a seatbelt. They're saying we're going to need a seatbelt in this ride. So the first thing you're going to do is you are going to sum up your centripetal forces. And if I look at the picture, both of the arrows are towards the center of the circle, so both of them are positive. So I'm going to have Fn plus W equals, now it's either going to equal mv squared over r or mr omega squared. Now I told you that in most cases it's mv, we prefer mv squared over r except when r is the unknown. But in this problem, I'm going to use mr omega squared because they gave me the omega. So I don't want to have to do a conversion if I don't have to. So I'm going to write this as mr omega squared. And if I look at my numbers here, they gave me the weight, so I know this number. They gave me the radius, so I know that number. They even gave me the angular velocity, so I know that. The only thing I don't have up here is the mass, which I can get from the weight. So I need to solve that, and then I can get this answer. So the mass is the weight divided by g. So I'm going to take 950 newtons and divide it by 9.8 meters per second squared, and that works out to be what? Hopefully some of you did this, so you can give me the answer right away. 96.9, right? 96.9. So now that I know, look, I now know that, I know that, I know that, and I know that, and they're asking for what's the force that the seatbelt needs to apply. That's the normal force. So if I move the weight to the other side, I'm done. So the normal force is going to be mr omega squared minus w. And so I'm going to have mr omega squared minus w. So plug those numbers in. 96.9 kilograms goes right there. The r, 6.5 meters goes right there. And the angular velocity, 1.8 radians per second goes right there. And 950 newtons goes right there. So if you solve that, that comes out to be what? The number I gave you is what, 1,091? 1,091 newtons. So there's your answer for part A. Now, part B is even less work, because in part B it says, what would your apparent weight be at the lowest point? So the lowest point, I'm going to have the weight still down. So the weight is still going to be down. Same magnitude as it was at the top, but the normal force is going to be up. You don't even need a seat belt at the bottom of the ride. It's just going to push you more into the seat of the ride. So this is going to be your normal force. That's going to be your weight. So the only thing about part B that's different is our descriptive equation is going to be slightly different. It's going to be Fn minus W equals mr omega squared. So it's minus because the normal force is towards the center of the circle, which makes it positive, but the weight is now, even though it was down here and it's down there, when it's down at the top, it's positive because it's towards the center of the circle. When it's down at the bottom, it's away from the center of the circle, which makes it negative. So now I can just move the W to the other side and solve for Fn. So Fn is going to be mr omega squared plus W. So without putting the numbers in, look at what I have here. In this one, I subtracted 950, and now I'm going to add 950. So the difference between subtracting 950 and adding 950 is doubling 950. 950 times 950 is 1,900. So whatever the answer was here, the answer here has to be 1,900 higher than that answer, because the weight part of the problem was subtracted in that, and now it's added. So if you add 1,900 to the answer here, you get 2991. Now, obviously, just to check it, I would put all those numbers in, but those numbers are the same numbers that I had up here. So that's that's 96.9, that's 6.5, that's 1.8, that's 950. But I'd come up with that answer. Now, part C says, what would the minimum time need to be per revolution? Because usually on these problems, people get A and B right. If they get something wrong, they get part C wrong. So in part C, it says, what would the minimum time need to be per revolution to eliminate the need for a seatbelt? Well, minimum time is the same thing as maximum velocity. So really, think of it that way. What's the maximum velocity needed per revolution to eliminate the need for a seatbelt? So maximum velocity would mean that I want this to go to, I want it so that there's no normal force, because anything above the maximum means I'm going to need a seatbelt. So what you do is you take this and make it 0, so that the only force required to change the direction is the weight. So this right here, to get the maximum, we make that 0. So my equation for part C is going to just be W equals either mv squared over r or mr omega squared. Now they're asking for the minimum time, so I can use either mv squared over r or mr omega squared, because I'm going to flip it over either way. If I get the answer in radians per second, I'll flip it over into seconds per radian and convert to seconds per revolution. If I have in V, I just always prefer V. Unless I have to use omega, I usually would prefer to solve for V. So I'm going to do that here. mv squared over r. So W equals mv squared over r. And my next step is I'm just going to replace W with mg, just so that I can cancel out the m's. So the m's cancel out. And solving for V, I'm going to just move the r over there, and take the square root, because that's v squared. So I move the r and take the square root. So v is going to equal the square root of gr. And I could have solved this for omega, which it would have looked a little different. So, but again, it doesn't matter. You could use mr omega squared. You could use mv squared over r. So in this case, I'm going to take the square root of g is 9.8 meters per second squared, and the r was 6.5. Is that what it was? 6.5 meters. So what do you get for the velocity? So this is the maximum velocity. If I go any higher than this number, then I'm coming off the rod. If I go any lower than that number, I'm not at the maximum. Jackson, you know what do you get? Take the square root of that. Okay, what did you get? Yeah, 7.9. For some reason, I thought you said 37 point. So 7.98 meters per second. So that's the v. That's the now this what I just did on the board. That's the maximum velocity. But I want the minimum time. Maximum velocity can be directly converted into minimum time. So the T minimum is going to be take this number and flip it over. So 7.98 meters per 1 second, I'm going to flip it over and put 1 second over 7.98 meters. And then I'm just going to convert the meters into revolution. Then I'll have the minimum time per revolution. So in one step, I'm going to go meters to revs. 1 rev is 2 pi, and then the radius was 6.5 meters. So if you solve that, I think you should get what the answer I gave was what, 5.12 seconds? 5.12 seconds. Any questions with that one? So that was 17. And I will be putting that up on YouTube.